Problem 6.2.55 is question number 12 on MyMathLab. And the picture that I have drawn is not to scale, so just a warning. It's tough to get a to scale picture on here with this graph paper, but the diagram looks like this, and the equations that you're given were here. So you have these two equations that were given, and then you're asked to pick which way you want to integrate with respect to. So I've chosen to integrate with respect to y because there's only one region. If we were to slice by x, you would see that you would have multiple regions. So I don't want to deal with that. So I'm going to integrate with respect to y. So I'm going to be slicing across. Okay, so everything has to be solved for x. And over here I need to just fix this up so x is equal to 8 minus y. So here's your equation, 8 minus y. And this was already given in a nice format for you. This is x equals y minus 2 squared divided by 3. So let's integrate with respect to y. Okay, so you need to solve for the limits of integration. You can use your calculator, or I generally just do them algebraically, and it's probably good practice for your algebra. So y minus 2 squared over 3 has to equal 8 minus y. So let's expand this. Square of a binomial, 8 minus y times 3. So on the left hand side you're left with y squared minus 4y plus 4, and on the other side you're left with 24 minus 3y. If I collect all my terms to one side and simplify, I get y squared minus y minus 20 equals 0. That's easily factored, and you get y minus 5 and y plus 4. So scroll back up here. So these points have a y component. The bottom one has a y component of minus 4, and that's this point. And this point has a y component of 5. So all you need to do is substitute back into one of the equations, and the easiest one is to substitute y equals negative 4 into into the equation x equals 8 minus y, which is 8 minus a minus 4, which is equal to 12. Oops. So this point is 12, and substitute y equals 5 into this equation, and you get 3. So this is the point 3 comma 5, and that's the point 12 minus 4. Now you don't need the x components of the intersection points because we're going to integrate with respect to y. So let's set up the integral here. And the integral, I'm going to have to go to another page, but I just want to get it set up. The integral is going to go from minus 4 to 5. I'll show you why, right? We're slicing in the y direction, and the lowest y value is negative 4, and the largest y value, just going to draw them over, is 5. So we're looking at slicing this region up between negative 4 and 5. So the integral is going to go from negative 4 to 5, and then again it's f of y minus g of y, f of y minus g of y. And go back up to the graph here, And if you go from left to right and you pass, I want to get a yellow color, if you pass a line left to right in that direction, the first curve you hit is your g of y, and the second curve you hit is the f of y. So f of y is 8 minus y, and g of y is the parabola, which is y minus 2 squared over 3 dy. So that's your integral set up. Now they did ask you to solve it in this problem, so I want to go all the way through to get the answer. And if you're going to make a mistake, it's going to be in the arithmetic. So let me get the antiderivative here. But before I can do that, I need to do a little bit of algebra to clean it up. So I'm going to try and save some space here. So this is minus 4 to 5. This is 8 minus y. And I'm going to try and be as clean as possible. I'm going to factor out the third here. Right, it's 1/3, so that I can expand out the square of the binomial. And that's y squared minus 4y plus 4 dy. So now I'm going to continue to clean this up algebraically and combine terms, right? And I end up with, I'm just going to move the constants together, 8 minus 4/3. I'm going to just collect the like terms. Then I get a minus y squared over 3, and I get a 4/3 y minus y dy. So I'm going to collect those terms, and I end up with, and this is where your algebra needs to be extremely clean, and you're working with fractions as well. So this is 20/3. All I did was find a common denominator here and combine them. So this is 20/3 minus y squared over 3. And then I combine the y terms, which is 1/3 y dy. Alright, so all I did was just do some combining here and cleaning up. Now I'm at the point where I can take the antiderivative. So the antiderivative is 20/3 y minus y cubed over 3, y cubed over 9, I'm sorry, plus y squared over 6. And I'm going to evaluate that between -4 and 5. And now we've got just a lot of arithmetic to do and keeping things straight. So 20/3 times 5 minus 5 cubed over 9 plus 5 squared over 6 minus the quantity 20/3 times -4 minus a -4 cubed over 9 plus a -4 squared over 6. Okay, so we've got some nasty fractions to just combine, but it's really nothing other than pure arithmetic here. And all I'm going to do is combine fractions and make sure I keep my signs straight. So this is at minus 80/3, this is plus 64 over 9 plus 16 over 6. So if I did this correctly, a negative and a negative makes a positive, so this is 180/3. I've got a negative and a negative, so negative 125 and a negative 64 leaves me with a negative 189 over 9. And then I got a 25/6 and minus a 16/6, which is plus 9/6. So, getting a common denominator, which is 18, and converting all the fractions, right? It's just a lot of arithmetic. And I get 729 over 18, which reduces to 81 over 2. And that's the area of that region.